In this video, we will check how to convert radian to degrees and vice versa. So the first question is asking convert the following angles into degrees. So first, let's just recall that 360 degrees is equal to 2 pi radians. So we will first write the relation, and then under this we will write pi by 6, which is the given angle, under 2 pi radian. So 2 pi radian, under 2 pi radian we'll write pi by 6 radian, and we don't know how many degrees it is. So let's write that as x degrees. Then we cross multiply and we write it as 360 times pi over 6 is equal to 2 pi x. We will use our calculator to simplify and write 60 pi equal to pi x. Divide both the sides by 2 pi and we get the final answer as 30 degrees. Next, 3.5 pi. So we repeat. So what we will do is first we'll write 360 degree equal to pi radian. Under 2 pi we will write 3.5 pi. So what the idea is to write radians under the radian and degrees under the degree. So under 2 pi radians we'll write 3.5 pi radian, and degrees we don't know, so we write it as x degrees. Then cross multiply. Then we'll use our calculator to solve, and then divide both the sides by 2 pi. Then get the final answer as 630 degrees. Next question, convert the angles which are given here into radians. So we have been given degrees. So first one is 67 degrees. So let's write the relation 360 degree equal to pi radian. This time we have got 67 degrees under 360 degrees, and under 2 pi we will write x radians because we don't know how many radians it is. Then we repeat the process, cross multiply. Then use our calculator, we can get 360 degree x equal 134 pi. Divide both the sides by 360 and we get the answer as 0.37 pi radians. Then we have 108 degrees. We repeat the process, cross multiply and divide both the sides by 360, solve and get 3 over 5 pi radians. So that's how we convert radians to degrees and degrees to radian. So we first write the equation, that is the relation between degree and radian, and then whatever is given, check what's the unit. If radian is given, write it under radian, and the other one will become, that is a degree will become x, and then cross multiply and get the answer for x. Similarly, if degree is given, write the number which is given under degrees and write radians as x and cross multiply and get the answer. Next, here we are going to use rotational dynamics equations for angular velocity and angular acceleration. So here it's given an object experiences an accelerated rotational motion. The data table below shows the angular position and angular velocity at t equal to 0 seconds and at t equal to 5 seconds. And then there is a table given to us. Calculate the average angular velocity between t equals 0 and t equals 5. So it's asking for angular velocity. The formula for angular velocity is delta theta over delta t, which means theta final minus theta I over t final minus ti. We'll use the table to find what is the final angular position, which is 12. T equal to 5, the angular position is 12, and t equal to 0, the angular position is 4, and the time is 5 minus 0. Then just calculate it, 1.6, and put the unit as radian per second. Next is asking average angular acceleration. So that's alpha. So we'll write the formula for alpha, which is delta omega over delta t, omega final minus omega initial over t final minus ti. And then we look at the table. Angular velocity is given to us. 18 is omega initial, 34 is omega final. Substitute the numbers and get the answer 3.2 radian per second square.